Okay, so this is the one where we don't have, what is it? We need an even power of secant or an odd power of tangent, and we don't have either. So you can experiment with that, and you can peel off a secant and a tangent, but that leaves you a single tangent that I cannot convert to secant. Or you can peel off a secant squared, but that leaves an odd power of secant, a single secant that I can't convert to tangent. So however you do it, you're messed up. So you can't do a use substitution on this particular type is what I'm trying to say. Here's what you can do. You can pick another color, and then what you can do is experiment. Well, I can change tangent into secant squared x take away 1 dx, and then distribute that and go, what I've got is secant to the 5th x, what else, minus secant cubed x dx, and there's no secant tangent use substitution here, and we're kind of stuck. We're stuck with a couple of integrals, and now what we have to do is talk about a reduction formula, So that's going to be the essence of this one. So what we're going to do is we're going to take a look at a reduction formula for powers of secant. And folks, then you'll have everything you need to know in order to tackle and conquer this kind of stuff. Okay, powers of secant and tangent of secant. So let's start off with integral of secant to the n power. N is not 2, integral of secant squared, easy. This is like n is 3, 4, 5, 6, 7, 8, 9, 10, and we're looking at n is equal to 5 and also n is equal to 3. And we're going to devise a formula for it. You ready? Here we go. This is how it's done. So what you do is you peel off, again, secant squared x dx like this. And if you do that over here, your power reduces from n down to n minus 2, like that. Okay, and we'll jump in here now, and we'll go, this guy right there, I'm going to do it by parts. And I'm going to let dv equals secant squared x dx. So v is tangent of x. Yeah, that's right. We're going to do it by parts. We're going to break off 2 and integrate it. That's the beauty of integrating by parts, because you integrate a piece of it and you derive the second part, and there's a formula where you put it together. The second part right here, that's going to be u. U is equal to secant to the n minus 2 power of x. So we have to derive it. Du is chain rule, baby, chain rule. Think of that as a power of secant. We're not integrating, we're deriving, okay? So down pops an n minus 2, and then you have a secant n minus 3 x, and the derivative inside, I don't have enough room, derivative of secant is secant times tangent, and then dx. Whoa. Chain rule, power rule, and then the inside is secant. I know. Loving it, right? So what we have is this integral, secant to the n x dx, changes into uv. So we have secant n minus 2x times tangent minus the integral of v du, all of that stuff. Look at that. So I've got an n minus 2, which is a number, and I'm going to pop him out. N minus 2 integral. We've got secant, actually the secants go together right there as secant n minus 2. Okay, we have integral secant n minus 2, okay, x, and then times, looks like we've got v to u, we've got a tangent squared. So we have a tangent squared x dx. Who's with me? Well, guess what we're going to do? We have integral of c. Once we have this, we can do this as a one-liner more or less coming up, okay? You'll see. I mean, this is painful though. So we have secant n of x dx, and this is real math. And we've got, it's equal to secant n minus 2x tan x, and then minus n minus 2. Okay, going to take some time to do this one. And watch this. We're going to write it as secant n minus 2x. And what does tangent squared do? Becomes secant squared x, take away 1 dx. Oh my goodness gracious. Okay, so we have the following. We have the integral. I'm going to try to save some ink here, so to speak. So I'm going to rewrite secant n minus 2 tangent minus, okay, so I'm going to do this, and I'm going to have an n minus 2 in front of these guys, okay? So it's going to be n minus 2 integral, look at this, secant n minus 2 times secant squared is secant to the n. That's right, we have a minus, we have secant to the n x dx. I'm going to split it apart, and then I'm going to do minus, and he's going to move in here and multiply. It's going to be minus a minus is actually plus n minus 2 integral. And what we've got is secant n minus 2 power of x dx, like so. So just as happens with integrating by parts, what we have is this guy here is the same as the integral we seek. So I'm going to take this, all of this, and add it to the other side as plus n minus 2, and you've got integral secant to the nx dx. So ultimately on that side, you've got 1 plus n minus 2 is really, believe it or not, n minus 1 integral secant to the nx dx. So n take away 1 of secant to the nx dx is found to be secant to the n minus 2 of x times tan x, and then finally way over here plus n minus 2 integral secant to the n minus 2 x dx. And folks, here comes the reduction formula. You ready for it? I'll put this in black now because this is the guide. So the integral of any integer power of secant, n is equal to 3, 4, 5, etc., n is equal to 3, 4, 5, of x dx is found to be equal to 1 over n minus 1. So I'm going to divide this over under each one, and it'll be secant to the n minus 2 x tan x, and then plus n minus 2 over n minus 1 integral secant n minus 2 power x dx. Doesn't seem like much, does it? But really it is, because you're replacing an integral that is an n power of secant. You're able to integrate part of it, and you're replacing it with a power that's 2 less than that, okay? So you're dropping the power, we're reducing the power. It's a reduction formula. All right, so how can we use that then on the following problem, that example we were working on? We had a secant to the 5th x, and I'll split it out as a minus integral secant cubed x dx. All right, let's watch it in action, okay? We're going to use it on the first guy. We're going to use the reduction formula on this guy right here, okay? So what are we getting? We're going to get, it's equal to, first thing you notice is n is equal to 5. So the formula says, here it is, and you'll find this in the table of integrals too. What you've got is n is 5, so we have 1 over 5 minus 1 is 4, secant of 5 minus 2x tan x. And then you've got plus 5 minus 2 over 5 minus 1 integral secant of 5 take away 2x dx. And then way over here is, I'll put this in black so you don't get confused, is minus integral of secant cubed x dx. With the formula, what we have is 1/4 really, you could have skipped that first step, secant cubed x tan x plus, looks like 3/4 integral secant cubed x dx. By its lonesome, And look at minus integral secant cubed x dx. You know what? I can put those two together, and I will. So 1/4 secant cubed x tan x. And now what we have is 3/4 minus 1 is minus 1/4 integral secant cubed x dx. And you know what? It's time for the reduction formula again. This time n is equal to 3. This is a long one, huh? But we're there, because now what we have is 1/4 secant cubed x tan x minus 1/4, watch out now, big old bracket. Now we're going to use the reduction formula up there for n is equal to 3. Now I know you can't see what I'm writing. Let's put that up there, but I can kind of see what's happening. So it's going to be n, I'm going to cut to the chase. N is equal to 3, so 1/3 minus 1 is really 1/2. And we'll have secant 3 minus, we're going to have a